Seed-based approach for near lossless to lossless image compression. Abstract image compression is inevitable nowadays as there is a huge transaction of data in the form of images. In this paper, a novel approach to achieve near lossless compression and further lossless compression is discussed. Here a seed-based technique over grayscale images to achieve better quality has been discussed. In this technique, 4 bytes of data is converted into 3 bytes with a transformation technique. Later a seed data is added to achieve near lossless results. Further, by adding additional seed data, lossless compression can be achieved. A metric called correctness ratio is used to measure the quality of the reconstructed images. The quality of reconstructed images is near lossless, i.e. very high when compared with JPEG approach at same PSNR values. Results of lossless compression are just comparable with JPEG-LS with slight compromise in compression ratio. Keywords: image compression, near lossless, lossless, comparison with JPEG, seed-based approach. Introduction. Image compression is a type of data compression applied to digital images, to reduce their cost for storage or transmission, as most of the data transmitted nowadays is in the form of images. These images can be either color or grayscale. For image processing tasks, grayscale images can be preferably used, as much of today's display and image capture hardware can only support 8-bit images and it is more complicated and harder to process color images. The grayscale pixel intensity value is stored as an 8-bit integer with 256 possible different shades of gray from black to white. A lot of redundancy exists in the use of 8-bit representation. This redundancy exists in 3 major forms: I.E coding redundancy, interpixel redundancy, and psychovisual redundancy. Compression can be achieved, if these redundancy can be reduced by suitable techniques. These image compression techniques will result into 2 types of compression, i.e. lossless and lossy image compression. Lossless image compression is usually required for applications like medical field where each and every detail is important. This is because lossy compression methods produce compression artifacts to images and sharp-edged lines become blur when using strong compression. But lossy compression is a good choice for natural images where slight loss is acceptable to achieve smaller file size. Lossy compression is usually based on techniques that remove certain information which the human eye typically doesn't notice. Mostly used lossy compression methods are transform coding such as discrete cosine transform, DCT, used in JPEG, or wavelet transform, used in JPEG 2000. Similarly, many researchers are trying with different transformation techniques. The most widely used methods of lossless compression in images are run length encoding, RLE, entropy coding and dictionary coders. Recently, researchers are working with prediction-based coding techniques to improve the compression ratio. In this paper, we discuss about a novel approach wherein 4 bytes of data is converted into 3 bytes by using a transformation technique by which lossy compression is achieved. A seed data is added to improve the quality, so that near lossless results have been achieved. Further, by adding additional seed data, lossless compression can be achieved, and these results are in PAR with JPEG-LS methods. 2. Literature survey. Many research works are going on to improve the compression ratio, improve the quality of reconstructed images, decrease the computation cost and reduce time complexity. We surveyed many papers and listed some highlights. Subramaniya, A. gives an overview of the major image compression techniques. The Joint Photographic Experts Group, JPEG, is a standard developed for compressing continuous tone still images. And it has been widely accepted for still image compression throughout the industry. JPEG can be used on both grayscale and color images. 1. Nethal Mohammed Al-Sharifi, discuss about the wavelet-based lossy image compression. To achieve high compression ratio in images using 2D dope GSM wavelet transform by applying global threshold for the wavelet coefficients 2. Giolika 1 and R. Stasisky, discuss about an efficient and simple context-based data modeling technique for lossless image compression. Similarly, as pre-processing stage of JPEG-LS, it uses only 3 contexts, which makes it time efficient, and does not force the message headers to be long. Enhanced, but more computationally complex versions of the method are also analyzed. Extensive experiments show that indeed, the new technique is clearly better from data compression point of view than the pre-processing stage of JPEG-LS, while its computational complexity is approximately the same. 3. Mamatha A.S., Vipula Singh discuss about a simple arithmetic calculation which uses, finding the difference between pixels, for near lossless image compression. They have used raster, orthogonal, diagonal and snake scanning methods. CR and PSNR for base value 16 is 3.628 and 35.1912 respectively. 4. Vishwanath P. Baligar, L. M. Patnaik, G. R. Nagabhushana discuss about the design and implementation of an image coding algorithm which uses a thresholding method. Threshold is the peak absolute error, PE, allowed in the reconstructed image. It has been shown that lossless edges with near lossless filled area give a high fidelity images. Results are compared with set partitioning in hierarchical tree, SPIT, and proven to be better. 5. As per Sini Sahalik, Mile Petrovic, Branimir Jaksic, Petr Spalovic, at lower PSNR levels, there will be noise effects from the compression methodology used in JPEG. Here contour-like structures appear, which are uncomfortable for better visibility. 6. We have discussed about some lossy compression algorithms using surrounding pixels method, pixel count method and byte shrinking method, where it is shown that at low PSNR levels, number of exact pixels in reconstructed image increases, thus reducing the contour effects that may arise in JPEG at same PSNR values 7, 12, 13. From the above survey, we got the motivation to improve the quality of images which give good correctness ratio compared to JPEG. Hence we came up with a novel seed-based approach to improve the quality of the images which is described in the next section. 3. Methodology. In this method, the grayscale image fxy is divided into blocks of 4 pixels. These 4 pixels are processed and converted into 3 bytes of data to produce a transformed image. For a block of 4 pixels, 3 byte data is generated. Later seed data is added to get near lossless and lossless results, which is explained with compression and decompression algorithms below. 4. Discussion of results. A. Results for near lossless compression. Above algorithm is implemented on standard test images and reconstructed images are shown in figures Fig 3 Fig.8. Left side are the original images and right side are the reconstructed images. We can see the quality of reconstructed images, which is very high. They almost resemble the original image. The quality of reconstructed image is measured by another metric called as correctness ratio to measure how many pixels are same as original in the reconstructed image and are tabulated in table 3 and 4. The compression ratio achieved by our approach is in the range of 1.3 to 1.5. Results show that, using this approach, reconstructed image is near lossless with high PSNR. The correctness ratio is also higher. The number of correct pixels as that of original using our approach are far higher than JPEG approach measured at same PSNR values. We have implemented lossless algorithm for the above listed images and obtained fully perfect images without any loss. Table 5 shows the bits per pixel, BPP, required for our algorithm as compared to JPEG-LS, and these results show that BPP is slightly higher, but this approach gives a simple and innovative approach for lossless compression. V. Conclusion and future scope. Using seed-based approach, reconstructed image is near lossless with high PSNR. The correctness ratio is also higher. The number of correct pixels as that of original using our approach are far higher than JPEG approach measured at same PSNR values. Lossless image also can be obtained with a slight compromise with compression ratio. This approach is less computation intensive, with time complexity O, and 2. It is simpler approach for compression as well as decompression. Further compression ratio can be improved by optimizing the encoding method of seeds. Acknowledgement. I wholeheartedly thank our guide Dr. Vishwanath P. Baligar for his constant guidance and motivation throughout the work. I thank our Vice Chancellor Dr. Ashok Shettar and Principal,
Dr. P. G. Tiwari for providing all the support and facilities required to carry out the work. I thank our HOD Dr. Nalini C. Iyer for her constant support and encouragement. I thank all those who has directly or indirectly supported to carry out the research work.